Hello, my name is Dr. Arpitha, Assistant Professor from Mathematics and Management Department, VIGNANA VJYEC. My topic is applications of ordinary differential equations. In this ordinary differential equations, I am going to discuss Newton's law of cooling. Okay, now what is meant by Newton's law of cooling? Newton's law of cooling is nothing but the statement is nothing but the rate of change of temperature of a body is directly proportional to the difference between temperature of the body and temperature of the surrounding medium. Okay, this is the definition of the Newton's law of cooling. What is the internal meaning? Suppose if you take a cup of coffee, if I am holding a cup of tea, okay, I am sitting in a room. So as long as the time increases, what will happen? Is the temperature of the cup of the coffee will be same? No. With respect to time, the temperature will be decrease. So what the Newton's law of cooling is telling that the rate of change of temperature of the body is directly proportional to the difference between temperature of the body and temperature of the surrounding medium. That is, let theta be the temperature of the body. Theta be the temperature of the body. Right? Now, rate means how we are going to replace the rate? D by dt. d theta by dt is proportional to temperature of difference between temperature of the body and surrounding medium. Here theta naught is the temperature of surrounding medium. Okay, temperature of surrounding medium. Right. Now, so theta is the temperature of the body, theta naught is the temperature of surrounding medium. And what is the statement is telling? A rate of change of temperature of a body is proportional to difference between the temperature of the body and surrounding medium. Right. So d theta by dt is nothing but minus k into theta minus theta naught. Why am I going to get minus k? Since with the respect of the time, the temperature of body is naturally going to decrease. That's why I'm going to write as the proportionality constant as minus k. Okay. Now applying the variable and separable method. Applying variable and separable method. Okay. d theta by theta minus t naught equals to minus k into dt. Okay. Now integrating on both sides. Integrating on both sides. What you are going to get? Integration d theta by theta minus theta naught equals to minus k outside into dt. Okay. Now, what we have to do? So, d theta by theta minus theta naught. We know very well that what is the integration of 1 by x dx log x. Now, theta differentiation is d theta by integration of d theta by theta minus theta naught. What we can write as log of theta minus theta naught equals to minus integration of t is t plus c, some constant. Okay. Now, if we take this logarithm this side, theta minus theta naught equals to exponential e power of minus kt plus some constant. Theta equals to theta naught plus e power of minus kt into e power of c. Theta equals to theta naught plus e power of c, we can write as c into e power of minus kt. This is the Newton's law of cooling. So, what's the Newton's law of cooling is saying that the rate of change of temperature of a body is directly proportional to the difference between the temperature of the body and its surrounding medium. Right. Here, what is theta naught? Theta naught is the temperature of the surrounding medium. Okay. Here, T is the time. And theta is the temperature of the body. So, this is all about the Newton's law of cooling. Now, let us discuss one problem related to this Newton's law of cooling, right? Now, let us read the given question. What they are given here? The statement, if the temperature of the surrounding air is 20 degrees centigrade. So, temperature of the air is 20 degrees centigrade. And the temperature of the body drops from 100 degrees centigrade to 80 degrees centigrade in 10 minutes. Okay. What is the temperature of the room? 20 degrees centigrade. Initially, what is the temperature of the body? 100. So, as the time passes, the temperature of the body, it is now 80 degrees centigrade after 10 minutes. Okay. Now, what they are asking, what will be the temperature after 20 minutes? We have to find the temperature after the 20 minutes. And also we have to find when will the temperature will be 40 degrees centigrade. So, we have, in first one, we have to find the temperature. In the second part, we have to find the time. Okay. Is it clear, friends? Now, solution. What is the solution here? Now, what is the Newton's law of cooling? What is the Newton's law of cooling is telling that? Rate of change of temperature is directly proportional to difference between the temperature of the body and surrounding medium. So, in the previous slide, I have derived the Newton's law of cooling, that is theta equals to theta naught plus some c into e power minus kt. So, this is the c into e power minus kt. Let us say this one is 1. Theta naught into c into e power minus kt. Now, so what is the given data? Let here theta naught be the surrounding temperature. So, this is air. Okay, surrounding temperature air. Theta naught equals to what they have given? 20 degree. Right. Now, the temperature of the body. Let theta denotes the temperature of the body. Okay, temperature of the body. Right. Theta be the temperature of the body. Right. Now, what is the temperature of the body initially? Initially means at T equals 0, the temperature of the body is 100 degrees centigrade. Now, as the time passes, T equals 0, theta is equal 100. Right? Now, after 10 minutes, what is the temperature? Temperature is 80. Okay, temperature is 80. Initially, at T equals 0, temperature is 100. After 10 minutes, temperature is 80. Okay, this is 80. Now, we have to find the temperature. Find temperature after T is 20 minutes. And in the second question, when will be the temperature? Temperature is 40. And what is the time? These are the two questions they are asking. Okay. So, what is the first condition? They have given the surrounding temperature theta naught is 20 and the initial temperature of the body is 100 degrees. It falls to 80 after 10 minutes. Now, first one. When so initially when T equals 0 and initial time, what is the temperature? It is 100. Initially, when T equals 0, theta value is 100. Substituting in 1, we get, and also we are having theta naught is, what is the value? 20. Okay. 100 equals to, what is the theta naught value? 20 plus c e power of minus k into t value 0. Okay. If we bring this one 100 minus 20 is nothing but 80. C e power of minus k into 0 is nothing but 1. So, we got the C value 80. Now, if we substituting in 1, we get theta equals to, already theta naught we are having 20 plus some C value 80, e power of minus kt. Let us consider this one as equation 2. Okay. Now, equation 2. Now, theta equals to 20 plus 80 into e power minus kt. Now, what is the second condition they have given? Second condition they have given, after 10 minutes, what is the temperature? After 10 minutes, it falls to 80. Now, substitute its values in 2. 80 equals to 20 plus 80 e power of minus k into 10. So, 80 minus 20, we are going to get 60. 60 divided by 80, we are going to get 80 minus 20. What we are going to get? 60. This 80 will come this side. 60 by 80, we are going to get 3 by 4. 3 by 4 equals to e power of minus 10 into k. Now, if we do this one, minus 10k equals to log e of 3 by 4. Okay. Already, we are having the log value of 3 by 4. That is k value minus 1 by 10 into minus 0.2878. K value we are going to get 0.02876. Okay, K value we got this one. K value we got this one. Now, K value is there. If we substitute this into theta equals to 20 plus 80 e power of minus 0.02876 into t. Okay, friends, this is the relationship between theta and t. Right, let us say this one as third. Right, let me explain in detail what we have done. With respect to the Newton's law of cooling, we have written the rate of change of temperature of the body is directly proportional to the difference between the temperature of the body and surrounding medium. Right. So, we are having the theta equals theta naught plus C into e power minus kt. Now, what they are given in the problem? Initially, the A temperature is 20 degrees. Let us consider that one as a theta naught. Theta naught is called 20. Now, if we take as the theta as the temperature of the body, initially, what is the temperature of the body? It is 100 degrees centigrade. And after 20 minutes, what is happening? The temperature of the body decreases to 80 degrees centigrade. So, with the help of these two conditions, what we are going to do? Now, first condition. And also in the problem, they are asking, after 20 minutes, what is the temperature? And when will the temperature 40 degrees centigrade? So, in this case, we have to find the time. In the first case, we have to find the temperature. In the second part, we have to find the time. Now, with the help of the first condition, so when t equals 0, theta temperature is 100. I have substituted in equation 1. With the help of the first condition, I am able to find the constant C. What is the constant C? I got the 80. Again, I am going to substitute this equation in equation 1. So, theta equals to 20 plus 80 into e power of minus kt. So, first condition, with the help of the first condition, I am going to find C value. Then, what is the second condition? If the time passes, so after 10 minutes, the temperature of the body, it decreases to 80. Okay. So, in this condition, I am going to substitute in equation 2. 80 equals to 20 plus 80 into e power minus k into t. So, 80 minus 20 nothing but 60. 60 divided by 80 is 3 by 4. So, we are getting, if we take log this side, we are going to get k value as 0.02878. So, with the help of the first condition, I got the C value. With the help of the second condition, I got the k value. Fine. Now, after getting the constant C and k, I am going to substitute these values in equation, in the given equation. So, what I got theta equals 20 plus 80 into e power of minus 0.02876 into t. If we observe clearly, in this third equation, what are the terms? Theta is the temperature and t is the time. Suppose if theta is given, we can find the time. Or else if time is given, we can find the theta. Okay, is it clear? Theta equals to this is the equation we got. Okay, this is the equation 20 plus 80 into e power of minus 0.02878 into t. Right. Now, what is our duty? Next one. Theta equals what we have got? 20 plus 80. Theta equals to 20 plus 80. In the previous slide, e power of minus 0.02876. Minus 0.02876 into t. Okay, right. Theta equals to 20 plus 80 e power minus 0.02876 t. Now, what they are given? We have to find theta and t. In the first problem, I am going to in the first slide. In the first slide, they are asking theta. After 20 minutes, after t is equal to 20 minutes, we have to find theta. What is the second problem? What is the time when theta value is 40? When theta value is 40. Okay. We have to find the temperature when t equals 20. We have to find the time when temperature is 40. Now, first condition. Theta equals to 20 plus 80 e power minus 0.02876. What is the time? 20. Okay. 20 plus 80 e power minus 0.02876 into, I am multiplying this one into 20. So already they have given in the problem what is the value of e power minus 0.80 into e power of, right? E power of minus 0.5752. Minus 0.5752 we are having this problem. So after substituting this value, I am going to get, this is the temperature. Okay. Now 20 plus 45 is temperature. So after 20 minutes, what is the temperature is? 35 degrees centigrade. Now second problem. Theta equals to 20 plus 80 e power minus 0.02876 into t. Now, they are given the temperature 40. 40 equals to 20 plus 80 into e power of minus 0.02876 into t. If you bring this one 20 this side, 40 minus 20 equals to 80 into e power of minus 0.02876 into t. 20, 80 this side, 80 equals to e power of minus 0.02876 into t. Okay, right? 20 by 80 nothing but 1 by 4, 0.25. E power of minus 0.02876 into t is equal to 0.25. If we write this logarithms this side, log e 0.25. Already in the problem they have given the value. So after substituting the value, e power of minus log e 0.25 by here 0.0287. So substituting the given value in the problem. So we are going to get, okay, log e 0.25 by minus 0.2875. Okay, we will get the temperature 82.20. Okay, so whenever the temperature is 40, we are going to get the time. Okay, already they are given the value. Okay, by substituting the what is the value log e 0.25. If we substitute this value, we are going to get the t value. Right. This is the Newton's law of cooling. So the main intention of the Newton's law of cooling nothing but the real life application nothing but. So with the respect of the time, naturally the temperature of any body will decreases. So we have with respect to time the temperature is decreasing. So we can able to find after time passes what will be the temperature of the body, or else suppose the temperature of the body is this one. So what is the time we can find? So the main intention here, this Newton law of cooling nothing but it is the application of the ordinary differential equations. Okay, is it clear? So in real life application also, I have given one problem that if we take a cup of tea, as the time increases, the temperature of the cup of tea will decreases. Okay, suppose if we take any item, so if we take in medicine, so the manufacturer will be dead as long as the time increases. Suppose today is the manufacturer dead. So as the time passes, what will happen to the medicine? Whatever the medicine purity is there, that will be decreased. Why? Because for everything there will be some saturation point. So this is a real life application of the Newton's law of cooling, and this is very important for BTech students. Definitely they will ask us one of the application of the ordinary differential equation. They will also define Newton's law of cooling and also a problem related to the Newton's law of cooling. So I hope you have understood this one. Once again, I want to define the Newton's law of cooling. What the Newton's law of cooling is going to define? The rate of change of the temperature of a body is directly proportional to the temperature of the body and its surrounding medium. Okay, thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.